Hi students, in this video I'll be going through two concepts regarding binomial theorem. Okay, so the first concept is what is the term, what do we mean by a term that is independent of x, right? And then the second concept will be the formula for the term. Okay, so let's start by talking about the term independent of x. Okay, so what does it mean by a term being independent of x? Okay, so let me use an example to illustrate this. So let's say we have the expansion binomial 2x plus 3 over x cubed. Then we power it to 4. Okay, so now basically what I'm going to do is I'm going to expand out all the terms. And then we see which terms are dependent on x and which are independent of x. Okay, so the first expansion will be n choose 0. Okay, so n choose now n is 4. Okay, then we have a. So currently now a is 2x, so a to the power of 4 minus 0. And then b is 3 over x cubed. So we have 3 over x cubed to the power of 0. Okay. Okay, then the second term will be 4 choose 1. Okay, then 2x 4 minus 1. And then 3 over x cubed power 1. Okay, the third term will be 4 choose 2. Then 2x 4 minus 2, 3 over x cubed to the power of 2. Okay, then the fourth term will be 4 choose 3, 2x to the power of 4 minus 3. And then we have 3 over x cubed to the power of 3. Okay, then the last term I'll write over here, 4 choose 4. Okay, 2x to the power of 4 minus 4. And then 3 over x cubed to the power of 4. Okay, so over here we should have 5 terms. Okay, so this one will be term number 1. Okay, term number 2, term number 3, term number 4, and then term number 5. Okay, so let's simplify all these terms. Okay, so 4 choose 0 is 1. Okay, then 2x to the power of 4. 2 to the 2x to the power of 4 is 16. So over here we will have 16x4. Okay, since this is power 0, so this whole thing is going to be equals to 1. Okay, so there's nothing extra from the 3 over x cubed. Okay. Okay, then next one, let's proceed. 4 choose 1 is 4. Okay, so I'm going to do some additional working. Okay, 2x to the power of 4 minus 1. 4 minus 1 is 3, right? So you will have 8x cubed. Okay, then times 3 over x cubed. Okay. Okay, then next one is 4 choose 2. So 4 choose 2 will give you 6. Then 2x to the power of 2. Okay, because 4 minus 2. So you get 4x squared. Okay, then over here, 3 over x cubed square, you'll get 9 over x6, right? Okay, then the fourth term, 4 choose 3 is 4. Okay, then 2x to the power of 4 minus 3. 4 minus 3 is 1, so it's just 2x power 1 is equal. So it's just 2x, okay? 3 cubed is 27 over x cubed will become x9, alright? So you have this. Okay, then finally for the last term, 4 choose 4 is just 1. Then 2x to the power of 4 minus 4. 4 minus 4 is 0, right? So 2x power 0, you'll get 1 now. Okay, so basically here you will just get just involve this term only. Okay, so 3 power 4, there will be 81. Then x cubed power 4, you will get x12. Okay, so just tidy up a bit. Okay, so over here you should get, okay, so over here, okay, so number times number, 4 times 8, 32, 32 times 3, you get 96. Okay, so you see, down here there's an x cube here, times 1 over x cube. If the x cube is below, means it's a 1 over x cube. So x cube times 1 over x cube, basically it will just cancel off. Okay, so there will be no more x term, right? So over here you just get a 96. Okay, then 6 times 4 times 9, you should get 216. Okay, x squared here and x6 below, so this will cancel off, and then this will become 4. So it will be 216 over 4. Okay, 4 times 2 times 27. Okay, if you calculate out, you also get 216. Okay, this x will cancel off with one of the x, so x8 only. Okay, then 81 over x12. Okay, so we are done with the expansion. Okay, so we are done with the expansion. Okay, so if you look across this row of terms, right? Okay, you look across this row of terms, this one is an x4 term, okay, because it's 16x4. Right, the next term you see the next term doesn't have an x, right? So this is what we call a term that is independent of x. Term independent of x. Okay, that means when you expand out, the term doesn't have an x. Okay, that means basically why does it not have an x? Because if you look at the previous step, right? Okay, basically what happened was that the x cancel off each other. You see this one, x cube cancel off with the x cube below. That's why it doesn't have an x. Okay, so basically that's what it means by a term that is independent of x. Right? So all these other terms all involve x. The first one is a x4 term. Okay, then this one is a x to the power of -4 term, right? Because if you use the law of indices, you get this. Right now. Then this one is actually a x to the power of -8 term. Then this one is x to the power of -12 term. So all the other terms are dependent on x. That means there's an x involved inside the term. X still exists in the term. It doesn't matter what is the power. Okay, so only those terms that are independent of x. Okay, that means don't have x1 is called independent of x. Right? So I hope that clarifies the concept. Right? All right, so sometimes we also say that the term independent of x, so in this case 96, right, is the x power 0 term. Why can we call it x power 0 term? Because x power 0 is 1, okay? X power 0 is equals to 1. So 96 can also be written as 96 times 1, right? So we can always replace the 1 with x power 0. Okay, that's why the term independent of x, we also call it the x power 0 term. Right, so that's the reason behind it. Okay. Okay, so now that we are done with clarifying the term independent of x, so the next thing I want to clarify is the general formula. Okay, the formula for the general term. Okay, so let's examine. Let's use the term number 2 to examine how the formula for the general term comes about. Okay, so I'll do my working over here. Okay, so the term number 2, let's observe it. What is the pattern that we can see? Okay, so we have this. Okay, you see, this is the term number 2. Okay, what do you notice about this number? This number and this number. They are all 1 smaller than 2, right? So that's why for the general term, right? Okay, this number here is always 1 smaller than the term number. So if the term is the second term, right, it will just be 2 minus 1 equals to 1. Okay, then of course, this one, this is n. Okay, so in this case, we are expanding this one, right? Okay, we are expanding 2x plus 3 over x cubed to the power of 4. So this is the n. Okay, so this is the n. So this is a fixed number. Okay, so this one is what we know as the r. Okay, later on in the general formula is known as the r. Okay, so what over here we will have n minus r. So n choose r, then n minus r. Then over here, this one, the 1 is the r, right? So this will just be the r. Okay, so in other words, if for general expansion, okay, for any expansion, okay, so let's say a plus b to the power of n, so the formula for the general term will be, okay, n, okay, see n on top, right? Choose r, okay, below, n choose r. Okay, then a, okay, the 2x is now the a, right? Okay, is the first term in the binomial, is the a. Will be a to the power of, you see, n minus r. Okay, then after that, this is the b, right? Okay, this 3 over x cubed is the b. Okay, b to the power of r. See, the 1 is the r now. Okay, so this is the formula for the general term. Okay, in any binomial expansion, right? Okay, so if let's say I want to write out for this expansion, 2 plus x. So usually the question will always give you a binomial, right? then they ask you to write down the general term and then simplify the general term. Okay, so the general term for this question will be TR plus 1 equals to n is now 4, n choose R, okay, then a to the power of n minus R, and then b to the power of R. Okay, so this will just be the general term. But then usually they will ask you to simplify it, okay, or tidy it up a bit. So what we will do is we will try to separate the numbers from the x. Okay, so let's say this one, this part. How to separate? Okay, so actually this is nothing got to do with binomial theorem. This is just the law of indices already. Okay, how to separate this? Okay, so to separate this, you need to apply this law of indices. A times b to the power of n will be a to the power of n, b to the power of n. Okay, so to separate this, now the n is this 4 minus r. Okay, so over here. Okay, so if I separate this, the a is now the 2, so it's 2, 4 minus r, x, 4 minus r. Okay, so let's separate this now. So it'll just be 2, 4 minus r, x, 4 minus r. Okay, then how about the one over here? Okay, this one also use law of indices. A over b to the power of n, it works in the same way. It will just become like this. Okay, so over here, it will just become 3 to the power of r. Okay, then 1 over x cubed to the power of r. Okay, okay, so just like this. All right. Okay, so this one, you may wonder how come I can take out to the side, right? Because I can also do this. Okay, so it looks like this, right? The one on top come out. Once it comes out, 1 will remain on top. Okay, because 1 times a to the power n will give you the a to the power n, right? Okay, so we separate out this, then we put all the numbers in front. Okay, so we put all the numbers in front. Okay, then we want to combine these two x terms together. Okay, but before we do that, let's see what will happen to this. Okay, so 1 over x cubed is x to the power of minus 3, right? So this one becomes like this, right? So it becomes x to the power of minus 3r. Okay, so you have 4 choose r, 2 to the power of 4 minus r, 3 to the power of r, x to the power of 4 minus 4r. Okay, so this one also same thing, use law of indices to combine together. A to the power of m times b a to the power of n, sorry. Okay, so must be same base, okay, will be a to the power of m plus n, right, same base. So over here will be 4 minus r plus minus r, add together, so 4 minus 4r. Okay, okay, so let's test it out and on one of the terms. Okay, so let's see. Let's say I want to find the coefficient of this x to the power of minus 8 term, right? So the coefficient is 216. So what I will do is I will just simply take this power and equate it to minus 8. Okay, because I want the x to the power of minus 8 term. Okay, so for the x to the power of minus 8 term, okay, I'll equate the power because now the power is minus 8. Okay, so I will get this. So r will be 3. Okay, then all I need to do is I take the 3 and put inside here, here, and here. Then I should be able to get my 216. Okay, so coefficient of x to the power of minus 8 will be 4 choose 3, 2 to the power of 4 minus 3, and 3 to the power of 3. Okay, so 4 choose 3 is 4, 2 to the power of 4 minus 3 is 2 times 27. So that's where I will get my 216, right? So you can see indeed the coefficient of x to the power of minus 8 is 216. So you can also go and try on the minus 12 and see whether you get coefficient 81 and so on. Alright, so I hope this clarifies the term independent of x. Okay, what does it mean? And then as well as help you to understand better about the formula for the general term, right, of a binomial expansion.